Hello once again, we are back on FORP and now we're going to be doing the laboratory activity number 5. How about we make things clear first? You get it? Because it's clear? Because it was overexposed? You get it. Anyways, laboratory activity number 5, the parts and function of camera lens. Cue the intro.
Yeah, short intro
To
lang.
truly understand the functions of the camera lens, let's start with the interior first. The lenses in the lens barrel are labeled in the following: the front element, the lens focus to infinity, the lens group, an aperture, another lens group, the point of sharp focus, the rear element, and the main sensor. The blue line represents the optical axis and optical path, while the red broken lines represent how an image will be formed. The difference between elements and groups in lens is that elements are the specific lens pieces used and how are they arranged to obtain a particular feature. The arrangement is the group. The front element is the first lens to receive light entering the lens from the scene. Its size also varies depending on the prime lens that you will use. The lens focus to infinity or sharp stars allows everything in your frame in focus no matter how distant it is to your lens. There are two sets of lens group in this lens barrel. And a lens group is an arrangement of convex and concave lenses that are placed variedly for specific functions like magnifying and focusing. The number of lens group varies between zoom lens and prime lens. Zoom lens have more lens group while prime lens have less. Then there is the aperture, which is the gap that regulates the amount of light that is allowed to pass within the lens barrel. It also controls the depth of field and the degree of sharpness that is expressed in the F number system. The lower the F number means a large aperture, meaning a shallow depth of field, compared to a high F number means a small aperture that has a narrow depth of field. Then there's the sharp point of focus, where the focal point is located. The focal point is the point where the lens causes the light rays to converge. It is also where the focal length is measured from the main sensor. The distance of the focal length specifies a lens into a wide lens, a normal lens, or a telephoto lens. Like the front element, the rear element is also a vulnerable lens that is coated with a special coating that reduces flare and other forms of aberration. Now let's move on to the exterior part of the lens. Fast talk, tapusin na natin to. Go! The filter thread allows you to screw on filters to achieve certain effects. The focusing ring is a section of the lens that rotates to allow the photographer to focus the image. The zooming ring enables motorized zooming that allows you to change the focal length in real time as you shoot rather than fixed prime lens. The lens specification markings indicates the length of the focal length in use. The distance indicator determines the distance from our camera to the subject. The depth of field indicator determines the depth of field, which is the distance between the nearest and the furthest objects that are in acceptably sharp focus in an image captured with the camera. Connected to the depth of field indicator is the aperture ring, which is a color on the camera that can be rotated to increase or decrease the aperture. Since the depth of field is under the relative aperture, the wider the aperture, the shallower the depth of field, the smaller the aperture, the narrower the depth of field. The lens mount is a mechanical interface that allows lenses to be interchanged. Lastly, the image stabilization controls reduces blurring associated with the motion of a camera during exposure. Yes, now for the last part. Now we will be talking about the basic categories of lens. First up are the types of lenses according to focal length. But before that, let's talk about prime lens and zoom lens. Prime lens have fixed focal lengths and zoom lens have interchangeable focal lengths. This is a normal lens. It is a prime lens, meaning it is fixed in the focal length of 35mm to 75mm, with 35mm being the standard size. Its focal length is neither short or high, and the field of view captured is that the same of a field of view from an eyesight. It is usually capturing the field of view 46 degrees from the optical axis. Next is the wide-angle lens. It is a prime lens in the sizes equal or less than 35mm. Its focal length is shorter, meaning a wider view or field of view, which is best for landscape photos. It usually captures an image 74 degrees to 85 degrees from the optical axis. Then lastly, on the types of lenses according to focal length, there is the telephoto lens, another prime lens that has a focal length from 70mm to up. This means that its focal length is higher, meaning a narrow field of view, best for distant objects. It encapsulates 28 degrees to 12 degrees from the optical axis. Next are two types of special lenses, macro lens and zoom lens. This is a macro lens. It is also a prime lens that typically has a focal length of 90 to 100mm. A longer focal length induces a shallower depth of field, in which in the image, the background is blurred. Macro lenses are great for wildlife photography, especially when photographing small creatures. Lastly is a zoom lens. A zoom lens is not a prime lens because it is not fixed, meaning the working distance can be adjusted as desired. It means that it can be a normal lens, wide-angle lens, telephoto lens, and even a macro lens if adjusted with the aperture simultaneously. Hence, the focal length is interchangeable, which varies the field of view. It is best for conventional photography that involves motion. That's a wrap!